Hello, everyone, and welcome to IMI's Masonry Education Webinar Series. Today's topic is how to design and install watertight assemblies. Our presenters are Scott Conwell, IMI Director of Industry Development and Technical Services, and Dean Moylan, Noble Company's Director of Architectural Services. Before we get started, today's program, we would like to inform you about our JBC Innovation in Masonry competition. We are seeking innovative masonry designs from you, whether they are imagined or completed projects. We have three categories, each offering an award of $10,000. If you would like to participate, head on over to imiweb.org, go to the main menu and select the Programs and Awards pull down to register. Register today and submit your projects by July 15th, 2024 for a chance to win. Just a couple reminders, today's webinar is eligible for one AIA HSW unit. Certificates and AIA credits will be issued within 2 weeks. We'll answer any questions you may have at the end of the presentation. You can submit questions at any time using the question feature in your control panel. Just make sure that you word your questions completely so that we can answer it properly. With that, Scott, if you're ready, please take it away.
Yes, we are ready. Thank you, Esther. I'm so happy to be co-presenting with my good friend Dean Moylan from Noble. And so let's jump right in talking about how we can use this material that we all know and love so well, ceramic tile, in very harsh environments, watertight environments, wet, intermittently wet, in some cases submerged, in some cases exposed to heavy duty steam. And we're going to start off, actually, I want to start off by putting things into perspective, talking about rain, something everyone understands. By the way, I happen to be in Chicago. Dean, I know, is in Las Vegas. Esther, who we heard from a minute ago, is on the East Coast in the Washington, D.C. area. So we're coming to you from all over the place. But in my city, Chicago, it rains 37 inches a year. The wettest city in terms of rainfall in the continental United States is Mobile, Alabama, 67 inches a year. So let's compare that to what a typical shower outputs, 2.5 gallons per minute. If that shower is used 10 minutes by 2 people a day, that's 50 gallons. And a typical 3-foot by 4-foot shower, that's nearly 7 inches of water every day, which equates to 2,500 inches per year. So as you can see, a shower is, it's a very, very harsh environment. And so we're going to look closely at showers and drains and membranes and how to handle all that water. So as an introduction, I wanted to make you aware that the Tile Council Handbook, which, if you're not aware, is a really great reference book. You should have this on your top shelf. I definitely recommend. I have it on my top shelf. In the front of the book, before we get to the methods, there's a section on environmental exposure classifications for floors, walls, and all these categories of tile that you see here. And the Tile Council and its member companies have really put a lot of thought into this. And there are 7 residential and 7 commercial classifications. These are guidelines. They're not meant to be all inclusive, but it's a good place to start. Now, I'm not going to read the text on the slide, but I wanted you to just see the 7 commercial classifications, environmental classifications, and what they address. And we're going to tie these to the individual methods as we go forward. So let's look at method F122. This is a floor method. We know it's a floor method because it begins with F. And this is the method for interior floors over on-ground concrete with a waterproof membrane and ceramic tile or glass tile. There's going to be a similar method that addresses stone tile as well. But looking at this method in the handbook, if we go down to the environmental exposure classification section, we see that it's rated for Res 1, 2, 3, and 5 or COM 1, 2, 3, and 5. There's also a handy dandy chart on page 45 of the 2023 book that summarizes all the methods and which environmental exposure classification they satisfy. So this F122 detail, these are the 4 applications that you can use that detail according to the TCNA handbook, which is not the end-all be-all authority, but it's a pretty good authority, and I definitely encourage you to do further research. So what are we going to do with all this water on our pool decks and in our showers and etc.? We need to we need to handle it. We need to basically, make it go down a drain, and we do that with slopes. There are all kinds of ways we can slope floors, and different degrees of slope, for everything from vertical to a 50% slope to a slope between 1 to 8 and 1 to 10 would be allowable under certain conditions. Slope between 1 to 10 and 1 to 12 would be allowable under certain conditions. The maximum slope of a ramp is generally figured as 1 to 12 or 1 inch per foot. But what Dean and I are going to focus on today is this 1/4 inch per foot criteria, which is the minimum slope, or it's the ideal slope really for any type of watertight application, a pool deck or a shower or a steam room. So keep that in mind. How do we achieve that slope? Well, really two general ways we can achieve that slope. Number one is the traditional method of floating a floor to a drain and tapering the sand and cement that we build up so it sheds that water to the drain. The other way, equally as good, is a prefabricated device such as this prefab piece of EPS with a waterproof coating, with a facer panel on it, I should say. It gets waterproofed over it, but and you see there's the built-in 1/4 inch per foot slope, and this is suitable for certain applications. But back to the tapered mortar bed, because this is done in the field and it's done to accommodate slope in rooms that may have irregular configurations and things like that. Primarily, that mud is made on site by mixing sand and cement in a proportion of 1 part cement to 4 parts sand, or a 1 to 5 sand. If it's a wet area, generally it's going to be closer to a 1 to 4 proportion. So in other words, more cement relative to the sand. And then water is mixed into that mix, and it's troweled on and floated to the drain. And you can see here, this is plywood that's protecting the linear drain underneath, but we can see here that if I draw the contour lines, this is the slope that is being achieved. And a good tile setter will be very adept at creating floors that slope to drain. That is in their skill set. It has to be in their skill set because it's a very basic skill. So let's look at this pitch plan. Primarily this big area of the floor. Let's say these are showers over here, and this is just a area of the locker room or something like that. So we've got a rectangular shower. It's not perfectly square, so we're going to have different slope in the short direction. It's going to be a little bit more drastic than the slope in the long direction. And how do we measure slope? Do we measure slope in the short direction, or do we measure slope in the long direction? And really, if you look at the ANSI standards, neither one. We measure slope from the farthest point in the room to the drain. That is how tile setters typically will create slope and measure slope, from the farthest point from the drain. So it might not make sense if you're used to thinking about roof plans and other types of ways to measure slope. That's not the way it's done, but in the tile world, that is the way it's done. So let's look here at the hypotenuse. That's 8'9". This room we know is 8 feet wide by 15'6". So we're sloping 4 feet here, and we're sloping 7'9" this direction. If we do the math, the hypotenuse of the triangle is about 1/4 inch per foot, which is ideal. In the short direction, it's a 1/2 inch per foot, and that is on the upper threshold of what's acceptable. But that is acceptable. Generally, you'd have to check local codes, but generally that sweet spot is between 1/4 inch and a 1/2 inch per foot. We don't want to be any steeper than a 1/2 inch per foot. And then in this long direction here, it's about 1/4 inch. So this would be a good pitch plan. This is a real pitch plan from a very complex tile job that I just wanted to throw up there on the screen to note, so that the audience knows that our tile contractors make these drawings. This would be a shop drawing prepared by the tile contractor, and they do have to think about pitch. It's first and foremost. Unfortunately, on some non-union jobs with some untrained folks putting in tile, we do see reverse pitch or no pitch, which is very bad. And again, and even the curb itself does need to have that a slight taper to it. So here we have the finished installation, and you can see Whenever you use large format tiles, since tiles don't bend, you're generally going to have to cut that tile so it conforms to the pitch of the floor. And you can see that happening here in this pool deck as well. Nice linear drain. Dean's going to talk about linear drains moving forward. So mortar coverage, since we are talking about wet areas today, I wanted to make everybody aware that 95% mortar coverage and embedment is the minimum that the code requires, that the ANSI standards require for wet areas. And that is achieved generally by one directional troweling, and if it's a large tile, that direction should be parallel to the short side of the tile, and then you achieve maximum collapse of those trowel ridges and maximum coverage. Also back buttering, which is applying the thin set mortar to the back of the tile, like you see here, also allows that facilitates, I should say, good coverage, because the mortar from the back of the tile will key into the mortar that is applied to the substrate. And again, notice this is a good tile setter because he's got those trowel marks all in the same direction and it's in the right direction. So this is we can be very confident that we're achieving good coverage. If there's ever a doubt, is the tile sticking to the substrate, just lift a piece of freshly laid tile, and this is what you want to see. We want to see, we don't want to see trowel marks, we want it to look like frosting on a cake, and that's a good indication that it's been good, the coverage has been good. So I know we're talking about failure, a little bit about failures, and one thing to watch out for, especially in swimming pools or anywhere you use mosaic tile, is that coverage is a little difficult, or can be a little difficult to achieve on mosaic jobs, because you may not be sticking the mortar to the tile. You may be sticking the mortar to the mesh or the dots. If it's a dot mounted mosaic or a mesh mounted mosaic, we're not saying now the front face mounted mosaic, you're going to have the best chances for success if you have a mosaic that's mounted on the front and you just peel that paper off at the end of the job. So we're not saying don't use dot mounted or mesh mounted mosaics. We're just saying that understand what you're adhering to is not the tile, it's the reinforcement, and know what that is. All right, a lot of information I'm throwing at you in the first 15 minutes, and then we're going to slow down. I'm going to give it over to Dean in a couple minutes here. But briefly, on substrates, understand the tile is, it can go over some substrates, it cannot go over everything. But particularly for wet areas, we really have to pay attention to what we're going over. So cement board is suitable for wet installations. Gypsum board, with the exception of this first one, gypsum board, you have to be real careful. And then foam board, it depending on the waterproofing that's on top of it, is possible. So cement backer board is the best thing you can use for a wet installation. Fiber cement backer board is also rated for wet areas, and then coated glass mat water resistant gypsum backing board is rated for wet areas. We wouldn't recommend gypsum wall board for wet areas. This shows you the ASTM standards of all those different backer boards. I think the idea I want you to understand with these slides on backer boards is that backer boards are not all created equal. There are good, better, and best backer boards. So definitely know what you're doing so you don't have all kinds of mold and mildew in your wet areas. Or the old lath and scratch is an excellent way to control the flatness of the substrate and to provide a very durable substrate for the finished tile, like we see here. This is an exterior installation, and by default, any exterior installation is you should think of as a wet application, because does it rain? Yeah, probably it rains. I don't know where you're designing, maybe in an area of the world where you don't get much rain, but exterior is generally considered a harsh environment. So with that, I'm going to flip it over to Dean to talk in more detail about membranes.
All right, thank you very much, Scott. I appreciate a lot of great information there. And, Scott and I have talked for a long time about getting together and doing one of these presentations. So thank you very much for including me in today's presentation. By the way, this is a great looking audience. Of all the webinars I've done, these folks look well rested and ready to go. So we'll jump into membranes, everything you want to know about membranes, waterproof membranes, but may have been afraid to ask. obviously, whether it's residentially or commercially, we're seeing the environment and the design in wet areas change quite a bit. Deluge shower heads, large oversized shower areas, cutting state-of-the-art linear drains, and it's changing our options as far as waterproofing. And there's also some basic blocking and tackling information I think is good to review as well, because there are a lot of ways that you can get from this rain shower stall to where you want to go. And as Scott had mentioned, all these systems are not created equal, and there's definitely a good, better, best, and the best practices. So let's keep moving ahead and take a look at that. Scott had mentioned some great information on the Tile Council of North America, and I've got my 2024 Tile Council of North America handbook here. I recommend whether you're a distributor, a sales representative, a specifier, an architect, a contractor, get your hands on that manual. It's just it's like the Bible of tile installation. But here are two classic details. The one on the left, detail 415, and Scott had alluded to it, the classic pre-pitch. The red line indicates typically a loose laid shower pan membrane. It could be a liquid, but in parts of the country where, by the way, this detail is still very popular, it's typically a PVC or a CPE sheet membrane. You've got your dry pack mortar, sometimes wire reinforced, sometimes not. Depends on the size of that wet area and the contractor's or architect's preferences. And of course, your tile or stone bonded to the top of the dry pack mortar. And again, a classic way of installing ceramic tile and natural stone, works great. Most often used with a clamping ring drain with weep holes. So you see pea gravel or crushed tile, there are positive weep protectors. There are devices. You want to make sure you don't get dry pack mortar in the weep holes. Looking to the right, this is more in line with ANSI A118.10, a bonded membrane, oftentimes occurring on top of the substrate, most often dry pack mortar, but that's changing as well. But the red line here you see could be a liquid, could be a sheet membrane. What's critical to note here is with the membrane on top of the dry pack mortar, you do afford and allow some of the crack isolation characteristics of some of these membranes to be enjoyed in the installation. And believe it or not, even in a typical shower pan installation, there's going to be movement. And if you have a membrane that can guard against that movement, more the better. But here as well, you see tying into a classic clamping ring drain with weep holes. So you're going to have to make sure you address that to make sure those weep holes do not get clogged up. Now, for years, it's primarily been sheet membranes, which could be PVC, polyethylene PE, or chlorinated polyethylene. That is the highest performing thermoplastic out there. But there's also liquid membranes. They've been around for a while, but there are differences in performance. There are differences in the expectations of what you are going to get out of that product. And oftentimes, some of these performance limitations are not that clear. So let's kind of go into it. Whatever product you choose, please make sure you always refer to third-party testing results if you want to validate claims regarding permeation, crack isolation, installation time, etc. Liquid membranes really got their start in the mid 80s. I was just getting started at Dillon Tile as a contractor sales rep, and all of a sudden you saw these liquid membranes on the market. And again, nothing wrong with a classic sheet, loose laid bonded membrane waterproofing system, but the fact that now you had a topical product that could be put on top of the substrate was very attractive to a lot of contractors. There may be a lot of great tile installers, but maybe their skill sets using loose laid or sheet membranes are not that polished. So this was an opportunity to do an effective waterproofing installation. Now, back in the 80s, you had longer lead times. I mean, in terms of you had sometimes have 7-day cures for some of these liquid membranes, multiple coats. Fabric was often required for all of these. Times have changed now. Some are one coat installations, some require sheet fabric, some don't. But one thing that is true about liquid membranes and sheet membranes, they're going to have different areas of performance regarding crack isolation and permeation, okay? Harkening back to Scott's earlier comments on slope, and they're important enough to actually repeat, this is a requirement, not a recommendation. You know, the TCNA manual is a collection of recommendations, okay? And you should know that any manufacturer's specific instructions for their product are going to supersede Tile Council of North America recommendations, but slope to drain is simply a requirement. It always has to be there. Most oftentimes 1/4 inch per foot or some variation of that based on the measurements and outlines that Scott alluded to earlier. And again, this is a very craft dependent installation method. I thought it worth repeating that, you know, it's going to require sand, cement, water, a knowledgeable craftsperson. They're going to use a laser level. They might use straight edges and a level, but ultimately they want to get to where they have a consistent slope to drain from their back of the shower to the drain, wherever that may be located inside that shower assembly. Now, what has happened for a variety of reasons, there are now a number of prefabricated pans, trays out there. And again, they're not all created equal. There is some confusion as to their performance levels and how they're offered up to the client, the end user. A couple of images here. On the upper left, you see an EPS molded pre-pitch that's going to require a membrane on top of it. Why is that important to remember? Because the product on the top right-hand side of the image already has a liquid membrane pre-applied to EPS foam. Now, to make things more granular, there's compression and point loading concerns about prefabricated pans and trays. And so the pounds per PSI can range from 35 to 45 up to 235, which means some of these products, you won't be concerned about penny round 1x1, 2x2. You won't have to use epoxy thin sets or mortars or grouts. Make sure you check, depending on the manufacturer, what's required for an effective prefabricated slope to drain waterproof system. Some of these products can actually be offered to you pre-sloped, pre-waterproofed, drain location where you want it on a custom basis. One of the big issues with waterproof membranes is permeation, simply the steam. And again, there are some misunderstandings. All membranes are not created equal. The amount of vapor that migrates through your wall assembly is going to affect ultimately the health of that shower. You don't want moisture to find a food source behind the wall assembly and create a microbial growth, which of course is a fancy way of saying mold. But there's a wide degree of performance between these products. ASTM E96 Procedure E is the gold standard. That would be 0.5 or lower. ASTM E96 Procedure E, okay? Now, what does that mean in the real world? Real quickly, there are membranes out there that go as low as 0.1. Now, remember, the magic number is 0.5 with ASTM E96 Procedure E. 0.1, if you had 10 showers, let's say 1,000 square feet, 10 showers over a week's time, that kind of permeation or lack of permeation transfer would mean you're going to have between 38 and 45 ounces of vapor in 1,000 square feet of wall assembly over a week's time. You're not going to worry about that. There are, however, some classic legacy waterproof membranes, sheet and liquid, by the way, that will be 0.1 and higher. What does that translate to? Well, you're going to have between 1 to 1.5 to perhaps 2 gallons of vapor transmission over 1,000 square feet over a week's time. So please look closely at what kind of membrane you're using and what are your expectations of performance. Crack isolation, obviously, I don't think you want to be installing anything over this. You see both prohibitive horizontal and vertical movement. There simply is no membrane crack iso-wise that's going to repair that. But realize there's an ANSI standard, ANSI A17.12, and I've got my ANSI standard book right here. Again, another important manual to have on your desktop if you're involved in the tile stone design, sales, industry, installation. But here you're seeing 2 classic failure areas, right around the drain, where the membrane ties into the drain, often a source of failure, where the shower pan meets the wall, that change in plane, oftentimes a source of failure. You see an image, a thermic thermal image, taken with a thermal camera that reflects the leaking happening at that transition from the shower pan to the wall. Of course, you can do a great job installing liquids or sheets, but the devil's in the details, which means when your curb meets the door, meets the sidewall, meets the shower door, please use your inside and outside corners. If you have escutcheon plate concerns, there are prefabricated escutcheon plate accessories. There are pipe collar fittings. These little things can make or break your waterproof membrane installation. And with that, Scott, I think I'm going to hand it back to you. Let me make sure. Yeah. Oh, don't forget your flood test. Do not forget your flood test, folks. It has to happen every time. I recommend ASTM 5957, essentially 2 inches of water for 24 hours over the entire wet area. Simply got to happen. And with that, Scott, I'm going to hand it back to you.
Okay. Yeah, thanks, Dean. Yes, some great information. I'm going to build on some of that. So let's talk about showers. And Dean just got done talking about membranes, and we're going to see how the membrane is applied in the shower. So as I introduce you to this idea of designing a shower and building a shower, understand that there are literally thousands of ways, millions probably, that you can build a shower. There's a handful of them represented in the handbook, the TCNA handbook, as shower methods, and those are some good places to start. But these are some of the variables: sheet versus a liquid membrane, the location of the membrane in the assembly, which is, it could be 2 different places or a few different places that Dean already showed. The different types of drains that Dean will address after this. But Dean mentioned, I want to take this opportunity, Dean mentioned the drains with weep holes, which is a conventional 2-stage drain versus a flange drain. And I guess I'll bring that up when we go into it. And then showers with curbs versus accessible showers without curbs. So here's just some eye candy for you. These are some large GPT gauge porcelain tile showers. Here you see this beautiful linear drain that you don't even notice it when you're in the shower. We've got profile strips along all the curbs. This is a recent project done in Chicago. We've got a couple of elements in the shower, like a bench and a niche, that in this particular job, these were prefabricated at the contractor's shop and then just installed on site, pre-waterproofed. Of course, these have to be sloped, just like the shower floor has to be sloped. Any horizontal surfaces need to have that slope. So the bench and the bottom ledge of the niche would need to be sloped as well. So let's look at the B415 shower. You can see the environmental exposure classifications here, which we talked about, but I'll take you through some high points very quickly. We've got the stud framing, the curb can be constructed from a variety of devices. And then we've got the pre-float here, the sand and cement. By the way, Dean, you may want to mute your microphone. We're getting some background noise, please.
Okay, thanks. Thank you. Yeah.
Okay, sure. So here's the pitch on the pre-pitch here, the sand and cement pre-pitch. And then we've got some blocking that's going to serve as a fastening device for the waterproofing and some other stuff. The drain collar, the shower pan membrane, this would be the sheet membrane that Dean talked about, the chloralloy or the CPE. Preformed corners at those changes of plane. I love how Dean highlighted changes of plane and where the membrane ties into the drain, 2 big points of failure. Clamping ring for that positive connection, weep protector. So this will be a drain with weeps. Acknowledge anytime you have a conventional drain with weep holes, and I think this is worth kind of saying, is that we are acknowledging that there may be standing water on the floor of that shower. It's not all going to slope to the drain. We hope it does. We hope 99% of that water flows to the drain naturally, but any water that stands on the floor of the shower is going to eventually migrate through the tile finish and through the grout joints, and that has to be addressed. And that's why we have weep holes in our drains to handle that moisture that may get below the tile finish. Vapor retarder, backer board. Now the seams have to be in the backer board have to be treated and taped with the latex modified tile fin set, basically with the fabric tape, the fiberglass mesh tape reinforcement, not traditional gypsum, that the carpenters would use, because this is a wet area. So we have to treat those seams as if they're a wet area. Now we've got this final layer of mud. So in this case, the waterproof membrane or the pan liner is sandwiched in between the pre-pitch and then the mud, the final layer of mud. So it's sandwiched in there. And this is kind of, in some parts of the country is the way they build, but this is just one way. So now let's shift gears and show you the B421. And this may, and you know, similarly, we've got the environmental exposure classifications. And by the way, the SR method I'm going to talk about, that's a steam room. So steam rooms are like showers, especially at the floors. So here we have the backer board now goes in at the beginning, unlike before where we had the pan liner sandwiched between the studs and the backer board. Here we have the benefit that the carpenters can build out the stud framing and the backer board, and then the carpenters can go away for a while, and the tile setters will come in typically and treat the seams and the backer board, the curb, the bond coat. There's no pre-pitch in this one. There's only one layer of mud, and here's that layer of mud, and that gets removed around the drain while it's still fresh. And then it cures, and then the waterproof, topical waterproofing goes on. Ideally, that should come out in front of the curb, so I'm acknowledging there's an error in this drawing that I made, but that should come out onto the floor by at least 12 inches. The clamping ring for the drain body itself, and then we're going to put the bond coat. The weep protection here would be in the form of gravel. There's different ways to provide weep protection, but the idea is that you don't, those weeps don't get obstructed and they're allowed to do their job. And finally, the finish. So that's the B421, different location of the membrane, and here's an exploded view. I want to say this is probably more common in commercial applications. So the B422, what's unique about this is it's got a different type of drain. It's got a drain called a flanged drain with no weep holes. And the reason is this is just, we're stopping all the water. So let's run through this. You've seen this before. This is all similar to what we've seen. But now notice the flange drain. We've got this big wide flange here. It would providing ample room to overlap the waterproofing membrane. So this methodology with the flange drain is we're going to capture all the water and direct 100% of the water into the drain. So we don't need weeps. Drain body, bond coat, and tile. And then the curbless. I wanted to talk about the curbless. Note here on the 2D detail that I thought I had an arrow fly in. There it is. Note that the recessed concrete. So if it's a curbless shower, we need to depress the concrete slab. Here it is in 3D. And sometimes that's forgotten about, or we don't know how far to depress it. There's a lot of coordination that needs to be done to save time later. So our stud framing, our backer board, our watertight treatment of those joints, like cannot emphasize that enough. Bond coat for the mud. Now here the mud is going to start sloping at the transition. Okay. Similar, we've got the waterproof membrane. This may be a little too far, so the first one wasn't far enough. But understand, we need to provide an extension for that waterproof membrane. The drain goes in, and everything else like we saw before, including the finish. And there is our curbless. So curbless, by the way, is not only for wheelchair accessibility. A lot of hospitality, chains and just clients want curbless showers because it's a more modern look. You don't have to step over a curb. It's just a personal preference. So we are starting to see some curbless showers just in the mainstream. So yeah, I wanted to just show you, this is what you have to do if that floor is not depressed. With a bushing hammer or an industrial floor grinder, take off inches of that floor. It's a very, very time-consuming job, part of the work that can be avoided. And then let's see, I'm running out of time here. The linear drain, Dean's going to talk about the linear drain, but I wanted to show the linear drain in the context of everything else. The benefit of a linear drain is we're only sloping in one direction, so it's a little simpler to achieve that slope, and it's just a cleaner look. So we've got, with the curbless now, we've got an option of having a threshold or no threshold. And then I wanted to draw your attention to the secondary drain outside the showers. That's a really, really good thing to have. I don't know that it's required, but it's always a good idea to have a secondary drain. So when you're drying off, well, there's actually 3 compartments. Here's the shower compartment with the linear drain, and you can see the shower curtain. Here's the drying off area and another curtain for privacy. And then this is just the, any kind of spillage can be addressed by this drain here. So this entire area is watertight. And then I've got the steam room, which is similar to a shower. I got to flip it back over to you, Dean, in a second here. what do I want to say about the steam room other than, well, you're probably going to want to insulate it, all right? And I know sometimes this is forgotten about, to slope that ceiling 1 inch per foot. And that's so you don't get condensation dripping on the occupants of the steam room. Also note that the movement joints, so we have the benefit here of looking at the 3D section where the floor meets the wall. Excuse me, this needs to be a soft joint or an expansion joint. So, and likewise up here, we have to have independent movement of the ceiling structure versus the wall structure versus the floor structure. So this is not a watertight concern. This is a universal concern, and it goes to the EJ 171 details in the TCNA handbook, talking about provisions for movement. All right, Dean, back to you.
All right, a lot of great information there, and we're I guess Scott and I are trying to put 5 pounds of coffee in a 3-pound can this morning, so we're moving very quickly. I left you off on this flood test slide, but one thing I neglected to talk about with crack isolation and membrane selection, that ANSI standard A118.12, there's standard grade, that's 1/16 of an inch. There's high performance, that's 1/8 of an inch or over. My simple recommendation to architects and contractors, if you select a waterproof membrane that has a crack isolation characteristic that hews to the high performance part of ANSI A118.12, you're going to have less concerns about movement failures. I will tell you, almost every movement failure I've seen in 25 years has been with a product that didn't meet that high performance metric. So food for thought when selecting your membranes. Okay, let's talk about drains. And Scott did some nice introductory comments on various types of drains. Our options have expanded. For many years, you had a clamping ring drain, and it looked a lot like this. You had the base, there were going to be weep holes, there was going to be a clamping ring. Of course, what happens between the clamping ring and the base, that's where your membrane usually goes. That's whether it's a liquid membrane or a sheet membrane. That's where the membrane goes, along with a silicone sealant or similar type of sealant. That compression gasket type of mentality, along with the chemical fusion, creates that watertight transition. Okay, been around for a while. Oftentimes you might walk onto a job if you're a commercial contractor, and that's what you have to work with. So, okay, just know that you have to make sure you protect those weep holes from any kind of dry pack mortar. Now, Scott did a good job of talking about bonded drain flanges, and this has sort of been an evolution where, as people have moved towards the ANSI A118.10 bonded membrane on top of the dry pack mortar or substrate, well, this bonded drain flange allows for you to transition right onto the drain body. Typically, a thin set's used to bond a polyethylene membrane to the bonded drain flange area. The tile is then affixed on top of the membrane. That is the sole source of locking in the membrane to the bonded drain flange. But the appeal here is you're getting rid of the weep hole concerns. Now, there has been an evolution in that concept. I want to quickly show it to you. Imagine a bonded drain flange concept, but dropped my strainer. You've got a clamping ring, okay? So the membrane comes onto the flange area, is bonded down with a high-strength adhesive. Clamping ring goes on top of it, so you have the very robust tying of the membrane to the drain body to prevent any residual water from collecting around the drain post, which can sometimes discolor natural stone mosaics. There are actually channels cut. I don't know if you can see those little channels cut into this drain. So the bonded drain flange concept has been evolving. Be aware of those changes. Now we might want to go linear. This slide was taken from a AI-approved presentation I do called Going Linear, but you may find out your client wants a linear drain, or maybe you want a linear drain for your own home. Well, as we said several times, they are not created equal. Back in the day, you were trying to make a silk purse out of a sow's ear. Trench drain, trough drain. The most popular term now seems to be linear drain, Division 9 ceramic tile natural stone. But as you can see here, they try to use a trench trough drain in a natural stone application. It just doesn't look very good, folks. Again, believe it or not, I took this image this was an upscale private steam room. And it looks like someone went out to someone's back industrial recycling yard, I don't know, and just took a good old trench drain and dropped it into a steam room. Very hard to waterproof to that. aesthetically jarring. Thankfully, we moved far, far away from that. One of the big attractions about linear drains is you can use larger format tile and stone. But please be aware, you might need to make sure that natural stone, that ceramic tile, meets dynamic coefficient of friction requirements. For some of us, we were raised on static coefficient of friction. That dog does not hunt anymore. But you can see where with a circular drain, which I've always wondered, why do we have a circular drain with square rectangular tile? I don't know. But you can see that's a pretty dated look on the right-hand side. Linear drains allow you to have a larger format natural stone or ceramic tile. Again, also too, a linear drain in terms of the organic transition from a wet area to the bathtub area or drying area. When combined with a curbless shower detail, it's very flowing. You don't have that jarring change from the wet area to the drying area because these linear drains allow for you the same type of material all the way into the shower area. You can barely see the linear drain in the back of the shower. One of the great attributes of linear drains, but they're not all created equally. Here you see linear drains that are literally around the perimeter of an upscale Wilshire hotel pool. And of course, the barely visible linear drains do a great job of keeping the water off those $1,000 per cabana couches. That's right, $1,000 per cabana. But and linear drains come in a variety of sizes from 2 feet, 3 feet, 4 feet, up to sometimes 8 feet in length. But they're not all built the same. Many linear drains have stainless steel drain bodies. They may be designed to be used with hub adapters. They may be designed to be coupled with a traditional clamping ring assembly, which we'll show you here. Here you've got the base of a typical clamping ring with a loose laid shower pan. You can see the dry pack mortar bed put on top of that, and a stainless steel linear drain, okay? Now, there may or may not be slope within that linear drain, and that's important because that's going to influence the performance of your linear drain. Here you see a stainless steel linear drain body. There is no slope in the interior body. It's got a membrane affixed by glue, a hot glue method, to the stainless steel body. Again, by contrasting a stainless steel body drain that you can see the slope has been built into the drain, that allows for water to start moving from drop one to your drain tie-in, which means you're going to have a higher gallon per minute performance out of that linear drain. But because of the sloped drain body, you'll have to make room for those kind of accommodations in your concrete substrate, okay? Now, there has been a move towards ABS and PVC solid linear drains. The drain sloping is routed with a CNC machine internally. And the attraction here is stainless steel doesn't have to worry about being 304 or 316. Also, too, it's easier to create that routed slope to drain in an ABS or PVC drain body. Now, besides that, is your linear drain going into an existing project you're renovating? Is it new construction? Where do they want that drain tie-in? Because most manufacturers offer a center drain location, and there's nothing wrong with that. But what if you require an offset drain or an end drain or maybe even a custom drain tie-in location? There are some manufacturers who can actually offer you those type of options, but be aware, I've actually walked onto jobs where the plumber and the designer, architect, contractor, no one was talking to each other, and the drain was not going to work with what was there on the job. Now, also too, depending on the waterproofing you use and the drain you select, that's going to influence your waterproofing. Here you see a stainless steel linear drain with a flange. A liquid membrane has been applied to the substrate, flashed over the flange of the stainless steel drain. It's critical if you're going to go this route, that transition from the substrate to the linear drain flange has to be very thorough, very robust, because stainless steel is highly thermoreactive. It's going to have a different rate of movement than the concrete substrate. You don't want to tear in that very critical transition from the substrate to the drain body. There are other options. There are a version of the clamping ring concept, where you have an ABS or PVC body. The sheet membrane is affixed to the drain body in combination with a high-grade sealant adhesive. that compression chemical combination creates a very robust attachment of the membrane to the drain body. That also is another option out there. Oops, let me go back. I got a little ahead of myself. Now, I've seen this happen also. You pick out a linear drain that's designed to use with a thin set application. Oops, someone detailed a mortar bed waterproofing situation. Well, some drains can make that adaptation through an adaptation modification kit. Some can't. Make sure when you're picking out your linear drain and your method of installation that they are compatible, okay? Very important. Beyond that, we're looking at various strainers. Some strainers come with 4 or 5 different stock options. Some companies can make custom strainers. The tile top strainer has become very, very popular, actually increases the minimal, the very kind of sleek, modernistic look of a linear drain, but realize you will significantly reduce your gallons per minute, okay, if you go with a tile top strainer. And here you see the comparison, tile top strainer to the left, traditional strainer to the right, really based on what you and your client want and being aware of the gallon per minute difference, okay? What if you've got a whole bunch of linear drains running end to end, which could happen in a pool facility, a hospitality facility, a hospitality type of installation? Well, some products have connecting links between the strainers. So you may have 4, 5, 6, 5 or 6 foot linear drains, but from a finished appearance, all you're gonna see is one long monolithic strainer. These are things to be aware of because maybe your client doesn't want to see a linear drain and then a piece of tile, a linear drain, then a piece of tile, okay? So be aware of those options. Real important if you're, wherever your stainless steel occurs on your linear drain, whether it's a whole drain body or just a strainer and clamping ring and some of the attachment screws, there's 304 and there's 316. 316 is marine grade. In fact, marine grade has to be used in certain health applications because you don't want that stainless steel to corrode due to cleaning practices or just not to be distasteful. The things that can come out of a human body are so corrosive over time. So be aware, most stainless steel linear drains are 304. There are some drains out there that are 316 marine grade. Make sure you check and make sure you know what's required for your project, okay? And this is kind of quickly shows you what 304 is made out of, and just know that 316 is resistant enough to wear and tear that that's what they put on ocean-going ships to hold up to the rigors of the outdoor world. So with that, I'm going to turn it back over to Scott and let him take the next module.
All right. All right, so I'm going to bring it home. Thank you, Dean. We've been doing a lot of talking about showers, steam rooms, drains. How does the waterproofing tie into the system? It's a complex. These are complex assemblies. Oh, Dean, if you wouldn't mind muting your, thank you.
Yeah, my water bottle makes a lot of noise.
These are complex assemblies, and we're not trying to talk you out of using tile. Tile is the greatest material ever, tile and stone and masonry, but they need to be installed right. So who is to say is most qualified? Well, a few years ago, the Tile Council of North America Committee, which is about a 60-person committee, and the meetings are attended by a couple hundred people in many cases. We came up with, and I sit on the committee, and I know Noble has representatives who attend as well, as the BAC does as well. We came up as a group with a list of criteria that we favor. And these are, folks who have gone through the training and the certifications, and in many cases, very rigorous certifications, and are qualified to install watertight assemblies as well as other types of tile specialties. Master Spec, we were pleased to see on their own, picked up much of this language, which they're making a reference here to advanced certifications for tile installers. And I want to talk just briefly about that. Another couple of examples here on some project specs. So what are the advanced certifications for tile installers? Well, first of all, I mentioned these are industry-wide certifications. So the logos that you see across the bottom of the screen, which basically includes every organization or company in the tile industry in North America. The manufacturers are all represented under the umbrella of Tile Council. So what we did about 10 years ago now is we have identified as an industry about 7 specialties, and these are what they are. I'm not going to read it to you, but these are the special skill sets required for the next level of success. See, these are the things that if a tile setter does not do properly in the field, you could have some serious failures. Know now that there are 3 types of showers that we test on. Membranes is a certification all by itself. So each one of these 7 is an independent certification, and actually each of these showers is an independent certification. So there's more than 7. But what these are, and these are open to union and non-union, these are industry-wide. It's a 3-tier process. So an individual tile setter has to have years of experience in the field. They can't be brand new in the industry. So once they've demonstrated they have experience, they go on to step 2 and they take a written test. It's an open book test, but we test them on their knowledge of how to navigate the TCNA handbook and how to look things up in the ANSI standards, because we think as tile setters, they should be able to use those books. And then once if and only if they've passed step 2, they go on to step 3, which is a hands-on mock-up that they construct, and that they do all the parts and pieces to a shower receptor or to a membrane installation, both liquid membranes, sheet membranes, and we've got this relatively new category now of single component membranes, which is essentially it's a liquid without the need for an anti-fracture fabric embedded in it. So these are the different showers that we test on. These should look familiar by now: TCNA 415, B421, and B421 curbless. Incidentally, these these showers and the membranes as well, they don't involve laying tile. They involve putting all the components into the shower before the tile. If you're a tile setter, we trust that you can lay tile. That's its own certification. That's the large format tile has its own certification. But the membranes and the examples I'm using, the membranes and the showers are, they don't even, we trust you can lay tile. We want to see if you can do everything else, all right, which is arguably more important. It's all important, but this comes first. So we have a whole series of critical points. These are not all the critical points, but these are some of the critical points that the installers are evaluated on this particular shower. Is the sealant present between the membrane and the drain flange? Like Dean mentioned earlier, that is a #1 place for failures, is that interface of those materials. So we need to make sure that that's a watertight connection. What about the height of your fasteners? What about the height that your waterproofing returns up the wall? Dean mentioned flood test. I believe I have a picture of what a flood test looks like, but that's, if your shower pan leaks before the tile goes on, it's going to leak when the tile's already on it, and by that time it's too late to fix without tearing out the whole shower. So everything should be flood tested in the field, and so for that reason we have flood tests as part of the certification. Here's the drain plug you can see, and this would be at the flood test stage. So here the membrane was cut too short, and I don't know if that's an automatic fail. I'm not involved in the evaluating, but I know it's at least points off. All right. Here we have the membrane going all the way to the bottom of the curb. Our evaluators do check and they pull the membrane up to see if it has sufficient coverage with the adhesive. In this case, yes. The backer board on critical point, if this is a true cement board, it can be buried in the mud bed. If it is one of the fiber cement boards or one of the non-cementitious materials, it has to be elevated, because that's a vulnerable edge, and we don't want that sucking up moisture. Okay. So back to the flood test, it's ASTM D5957 is the true ASTM standard. Oftentimes on jobs, you'll just fill the receptor with water overnight, and or even at lunchtime, you come back a couple of hours later and check. If there's still water at the same level, it's deemed to be a watertight shower. So there's various degrees that you can, but truly it's a 24-hour test. If you're wondering why this green material, which is the waterproofing membrane, doesn't go all the way to the shower head, the answer is it should. And in this case, the owner didn't want to pay for the waterproofing, and it was a very contentious issue. And the tile contractor didn't want to cut corners and only go up 12 inches. But in the end, they did it because the owner required them to do that. So the height of fasteners is dictated by the ANSI standards. And so those have to be a certain height above the finished curb, like you see here. And we're not trying to, turn everybody on this call into expert tile setters, but what we want to do is show you that it is an involved craft, and there are many, many critical points that go into installations of membranes, installations of showers and water features. Real quickly on the membranes, by now you know there's two basic types, liquid and sheet. The challenge with liquid membranes is to get the thickness correct, because you could put it on too thin, you could put it on too thick. That liquid needs to go on at the specified thickness, and that's not a universal number. Noble may have a 40 mil wet mill recommendation, and whereas Mapei or Laticrete may have 50 or 30. I don't know, but the important thing is to read the instructions, make sure you put it on at the recommended or the required thickness. So gauging the thickness is a challenge for liquids, and the overlapping is the big challenge for sheet membranes. They both have the challenge of these terminations and connections. Okay. Esther, I'm coming to the end of my slides because we do want to leave a little bit of time for questions, like a minute or two. But let me get through these. So overlaps here you see in the sheet, in the anti-fracture fabrics. Here we've got the treatment of the pipe penetration on this mock-up. So these are photographs of actual ACT testing and certifications. All right, so we have evaluators watching the tile installers do all these activities. They're given a certain amount of time, and they need to demonstrate that they're adept in these skills. So we take our trade very, very seriously, and we understand that you just can't, you can't call yourself a tile setter because you watched a YouTube video. It's a skilled trade, and it's an important trade, and tile's been around for millennia, and we'd like to see it continue to be around. And we didn't have waterproofing membranes in Roman times, and maybe we didn't have linear drains in Roman times, but so we're introducing all these really cool stuff into the assembly. So for that reason, it's important that our workforce has to not only go through the training, but be re-educated and retrained and constantly updated on this technical information as it changes. So Esther, do we have any questions for Dean or myself?
Yes, we have plenty of questions, but before we dive into those, just another quick reminder to everyone that certificates and AIA credits will be issued within 2 weeks by email, so look out for those. All right, let's dive into some questions. The first question I have is from Jeffrey. He would like to know, how do you flood test a curbless shower? Do you construct a temporary curb?
Sounds logical. I don't know. Dean, yeah, go ahead.
Yeah, typically what happens is, great question, by the way, and this was, if you're going to do, I would recommend, of course, there are sheet membranes and liquid membranes. If it was a sheet membrane, what you would do is that membrane would extend beyond the area where you're going to terminate it, and then you would prop up that membrane. It might be, I've seen people use literally 2x4s to create a raised profile. I've seen them use bags of cement, but essentially when that sheet membrane hits the entrance or exit of the shower, where it's going to be terminated because it's a curbless shower or transitioning out into the drying area, for the purpose of a flood test, you do your inside corners, all 4 inside corners, but you just keep that sheet integral, one piece, propped up, so you can do your flood test. After your flood test is done, let the water out of the system, and then of course you're going to cut and trim that membrane to where it transitions to, whether sometimes there's a linear drain at the doorway or entry of that shower, or else you're transitioning to whatever. And I would recommend, if you're doing a curbless shower, make sure you waterproof the drying area, because water is going to get in there. Scott, I think, alluded to that earlier, but that's the way you would handle. You had that sheet membrane propped up. Now, if you had a liquid membrane system, you would have to have some sort of fabric and liquid to create that temporary upturn. So you do a flood test and then trim it out and remove it once the flood test is done.
Thanks, Dean. The next question is from Stephen. He would like to know, how are the corners of the flanges on the linear drain dealt with? If they are not covered completely, there appears to be a leak potential.
The corners of the flanges of the linear drain. Dean, do you have something that shows that? I can go to my exploded view.
Well, I think, let me see if I can go back to an image here. Back to an image here. Okay.
These corners here, this is all one this number 35 linear drain assembly. This is all one continuous piece. So this is already going to be kind of, water. It's all one piece and it's metal.
Yeah. Well, typically what happens is when you have a linear drain, some linear drains can literally be installed right up to the back wall. Okay. I know that in most cases you have the ability with a liquid or a sheet, because obviously, depending on your method of waterproofing, you're going to have the waterproofing transition off the body of the drain up into the balance of the substrate and the vertical upturns. Perhaps I'm oversimplifying, but whether it's a liquid or a sheet membrane, you're going to address the flanges. I assume you're talking about the flanges of a stainless steel linear drain. You got to make sure that the transition from the substrate and wall waterproofing is uninterrupted and continuous onto the drain body at all four corners and on all four edges.
Yeah, exactly. Like you see here, the pink being the waterproofing.
Okay.
Thank you, Scott and Dean. We are at the top of the hour, but I would like to ask one more question before we end today's webinar. This is from Mario. He would like to know, in what applications would you recommend a liquid or two-component membrane over preformed sheet membrane?
So one over the other, or one versus the other. It's really, yeah, I mean, that's a decision that the contractor often will make. I mean, as long as they are both installed per the manufacturer requirements, you're going to be fine. Now, some of the TCNA methods specify one versus the other, but I don't think we can tell you that, oh, sheet's better than a liquid, or a liquid's better than a sheet, or a single component is better than both of them. I think it's just really the contractor's preference. And I don't know, Dean, do you have anything to add?
Yeah, I mean, like, I think most companies out there today have both liquids and sheets. So there are particular pros and cons to either one of those methods. I would say look at the performance metrics. I mean, I come back to vapor migration and movement are the two biggest enemies of membranes as far as failures. So whether it's a liquid or sheet, if you find superior crack isolation performance or superior vapor migration permeance performance, look to those performance metrics to give you the peace of mind you want. Okay.
Right, and I would add, yeah, if you're trying to get double duty out of your membrane, if you want it to function as a crack suppression or a crack isolation membrane and a waterproofing membrane, then those are, that's probably going to be a anti-fracture fabric embedded in a liquid, because I don't think a sheet will give you anti-fracture. I mean, I don't think, sorry, a liquid will give you anti-fracture.
Yeah, again, I would say look out. There's an ANSI standard, A118.12. It's neutral. It doesn't have any dog in the hunt. Just take a look at that A118.12 and just take your favorite liquids, take your favorite sheets. Because here, the point I make with my presentation is you can have the best waterproof membrane in the world, but if it doesn't resist movement very well, you could have problems. Okay, so and if you look at most specifications, they're hand in hand. Most spec writers will put waterproofing / crack isolation, waterproofing / crack suppression. So they are sort of walking hand in hand as far as successful performance in what areas.
Scott and Dean, thank you. And thank you everyone for joining us today. That concludes our questions. We have many more interesting programs coming up. Please visit us at imiweb.org to register. We look forward to seeing you there, and have a great day.
Thank you very much. Everyone be safe.